How to scale uh, in 1200, 1500, like you're scaling in S7-300. Inshallah, in this video, I will explain this point, how to easily scaling like S7-300. I am Ahmad Taha, lead commissioning automation engineer. Okay. This is my first video in English language for automation. Okay, for any comment, you can type it in comment section to help me to improve our video, inshallah. Okay, now to scaling, as Siemens, you scaling for 1200 and 1500, you use two block, norm X and scale X. In norm X, you put your source for analog input and put your range from 0 to 27,648, and scale, you put what is your actual value, for example, from 20 to 150. Okay, this table, what is the range for this signal as integer, start from 0, maximum is 27,648. This range for analog. Range, for example, it use milliampere. Milliampere maybe for from 0 to 20 milliampere, or from 4 to 20 milliampere. Okay, you can use this. Okay, but alhamdulillah, after searching, I found someone is called Denison. Okay, he make block it easily to using to scale and scale, to be easy to scaling analog input and analog output by one block, and he had add more features in this block. Inshallah, I will mention in description of this video this link for this site, and also anyone, if he need this block for this analog scaling, if you're it, because he used the version 11, version 12. I have many versions. I can share this version you need. I have now in version 14 and also in version 18. If anyone here require it, I will share as per his request. Okay. Now to scaling. Now you can use this block. It's easy. Now you can delete this one. For example, this is scale. Scale it used for analog input. Why my analog input? For example, it will be IW100. For example, this actual analog input. High limit, I can, for example, put on high limit 100, low limit 0. Unipolar, bipolar. Unipolar, it means if I open here. Okay. Unipolar, you can say it from positive reading. This unipolar. Bipolar, you mean you reading positive and negative. So your range, it will be, if I open block here, see here, if you are unipolar, it will be 0 to 27,648. Or if you bipolar, you're reading positive and the negative range, it will be start from negative 647 to 27,648. Okay, if you what you want this reading, you needing negative area, or only you need positive area. So now I will use only positive area. So I will now put 0. Okay, just return for error. I will now type ART for return. Okay, now okay, I can click right, define tag, I make it global number. Okay, automatic have address. This output, this reading, actual reading, I will say, for example, level. So click right, define tag, global memory. This is defined. Now it can easily to you now to use scale analog input to make PLC have availability to read analog input. For analog output, you can use Un-sclae. Okay. Now your input, for example, I have now, for example, speed. Okay, I click right, define global memory. Okay, high limit, for example, maybe 60, I mean 60 hertz. Low limit 0 hertz. Now because it's unipolar, I put 0, enter. Now I type this one, ERT, for example, 2. So I define global memory, define. Now output, for out it will be QW, for example, 100. Okay. Now you now use Un-sclae for analog output. Yani this for analog output and this one for analog input. Okay. This is how to use block. And there is some comment for his page for use his block. One of this comment, yes, if you have analog, for example, CPU 1200, it has analog input 0 to 10 volt. If I want to use it for 0 to 20 milliamp, how can I use? He have suggestion for this point. You can use shunt resistor 500 ohm. Now it will be acting like 0 to 20 milliampere. Also in this block, if you have, for example, your analog input from 0 to 20 milliampere and your signal it from 4 to 20 milliampere, he have additional block for this. See this from 0 to 20 milliampere. You see now you have 1 to 0.5 or 0 to 1. This for different from 0 to 4 milliampere. It's about 0.5, 0 to 0.5. This if you use your analog input is 0 to 20 milliampere, you want to use it from to be 4 to 20 milliampere. Additional point, now you can use it this one as programming. You need to hardware configuration. For example, I will now go here to device network. Okay, this one. Okay, let me catalog hardware. Okay, let's select, for example, I use this CPU. Okay, maybe let's add new one. For example, this view. I like to work with 1500. For example, this one. Now, this for protection. I don't want any protection. I put this legacy. Again, back to the now asking for protect. Because you don't use the Siemens laptop, you use your normal laptop. So I prefer to not protect or put any password during configuration. In final end, if you require to put password, put and final end. But at beginning, I prefer didn't put any password. Next. So I also make legacy to communicate with anyone to not face an issue in communication. Last one for access, full access. I mean, I don't want any password right now, so I now finish. For example, I will add here analog input. Okay, for example, I will add this one, this analog input 8U. It refers to volt. I read it to current. RTD is thermal. TC is thermal. I will add this one. Now I've opened here. Click here. Now go for input. This template. Input parameter. See here. I have, for example, can manual to change it. Okay. Now I have regions. What you need to use: voltage or current for wire to wire, or resistance or thermal. Okay. Now I will use, for example, for wire. On for wire have option reading to be 0 to 20 milliampere, 4 to 20 milliampere, or positive to negative 20 milliampere. This depends on your instrument. That is the range of your instrument. Or you can select it two wire, and this wire you have only two option 4 to 20 milliampere. Okay, if you select this one as voltage, okay, it will be have two options to be positive, negative 10 voltage, or you have several. But normally, mostly we use current as 4 wire, 2 wire, because in voltage we have drop voltage may effect in reading. Okay, now I got it. Now I go here for IO tag. This addresses I should use in program. What address I should use for analog input? This first one, it will be IW0. Last one, it will be IW14. The area for analog input is 2 bytes, so it's 0, 2, 4, and 2, 14. If I add here analog output, for example, this analog output U, it refers to volt, I refer to current, H mean high feature. I add this one. I will go here, general, I will go here for output. For example, channel 1 from okay, template, no, not from template, I will put manual. Okay, manual. Now it will be volt or current. Volt, it will be positive negative 10 volt, or 0 to 10 volt, or 0 to 5 volt, depending on your instrument. Or current, it will be positive negative 20 milliampere, 0 to 20 or 4 to 20 milliampere, depending on what you need. If I go here for IO tag, this address what will use in programming. I hope this video help you. For any clarification, you can type in comment. I made this video in English because many people asking to explain in English. I normally explain in Arabic. I hope this video help you and support you. I hope to have enough time to make new videos as soon as possible. Assalamu alaikum wa rahmatullahi wa barakatuh.